And politicians are aware that if they, I guess, enhance this impression, or at least they do not counteract this impression, then they will lose votes and they will be out of government. They will lose their seats. So the real trick for scientists is to get over the view that not necessarily does a low-carbon future, that tackling climate change have to be a reduction in the standard of living. It may need a change, it will need a shift in the way in which we operate, but we have to get over a much more confident future, which, from what we've just heard, may seem a little contrary, but nevertheless, unless we do that, we will lose the battle in converting climate change policies into real action and change in the greater public around the world. Thank you.
Thank you very much, Professor Pan and Dr. Drewry, for your important comments and observations on some of the key policy issues that our policymakers are dealing with, and also suggestions on how science can and should play a much more effective role in informing that policy debate. And now it's time for questions from you, from our audience, and I think we have a number of them right here. Oh my goodness. Okay, well, let's go. We have not much time. So, all right, let me start with a question for each or any of the panel members. What is your one silver bullet, if there is one, that you believe can be implemented with most immediate effect to stop us reaching that critical tipping point in climate change? Would anyone care to speak on that issue?
Let me make it. It's very simple. Everybody has got a budget for carbon emissions for their daily life, and then if it exceeds, his emission exceeds that amount of budget, and then he has to buy, and if he does not exceed, he's got some surplus, and then he can sell. And then, so if in aggregate, then we would have the total amount of emissions consistent with the 2-degree target. I think that's it. But that budget has to be equally allocated. Otherwise, because we should not say that the rich guys should get more and the poor guys should get less. And then, if everybody has the equal share of the emission space, and then nobody would dispute that we should get more, we should get less, and then the sustainability is somewhat guaranteed.
Anyone else?
Yeah, well, I think it's clear from the discussions we've had so far this morning that there is no one silver bullet, that we in fact have to force ourselves to act on complex uncertainties in parallel on many agendas. But if there's any key issue to complement what Professor Pan is saying is clearly that there's enough scientific evidence to show that among the very many regulatory options we have, that probably a carbon tax is the most immediate and most effective way of acting quickly. Because I think what the whole morning shows is that we need to have a very fundamental shift in values, in ethics, in global collaboration, which takes time. It will take a long time, and we're seeing the difficulty in terms of just getting 200 countries to collaborate just on climate. So to act quickly, you probably need to combine Professor Pan's suggestion of, in fact, caps with carbon tax, which can create incentives, which then can be plowed back into poverty alleviation efforts.
Thank you. Here's another question that I suspect many of you have heard. And it's a key issue, as Dr. Drewry said, in informing the general public. Do you think the climate change is a false problem? Many people around in the U.S. in particular, as we've seen from yesterday's election, are electing people to government who are either climate skeptics or outright climate deniers. So this issue is coming up increasingly in certain circles, but the point that was made earlier that even without human intervention, the climate is still changing. And I wonder if anyone would like, you've talked about it today, but if you could give a concise response from a scientific perspective, that would be the question. Is climate change real? Is it caused by humans? That's the, of course, what the IPCC has come in. You may laugh, but this is still an issue in many members of the public and policymakers' minds.
I leap in here, which is a very difficult area. I think the graphs that we've seen about the way in which our planet has changed over, let us say, the period since the last ice age, or going beyond that for maybe several 100,000 years, and to show that we're actually entered a period which is extraordinarily different from the cycles and changes that have happened in the past, and to indicate, therefore, that we are moving into we're sailing in completely different waters from the past. There have been changes in the past. There is a rhythm to the Earth, the way it has been changed due to our rotation around the sun, which drives a lot of our climate in the past, the ice ages. But what we've now seen is something additional and a greater change. And I think if we can drive that home, we're not denying that change has happened in the past, but now it is being driven in a different way, and it may be for others to say actually how we make the connection with us personally. But the fact is, climate has changed more rapidly.
Yeah, I think this is actually a very simple question, and it's a question of the past. And I think we have a tremendous thank to give to the IPCC for its phenomenal contributions to our understanding that not only warming is unequivocal, but also that humans are the key driver of change, even though there are many uncertainties still remaining, and that these uncertainties so far go only in one trend. There's only one trend line, that the more science we know, the more vulnerable the planet seems to be to our interference, and that we so far cannot find any examples of negative feedbacks that would help us, that in fact the feedbacks seem to be reinforcing warming rather than cooling, but that so far we have very clear evidence that the planet is trying to buffer as far as possible. I think that's a very compelling story. But I think there's something to add here, which in my mind is really important, which is that if you climb out of climate science for a while, and you just look at the other sciences which are connected to climate science, they go in the same direction. So you can sort of say have uncertainties on a wide variety of research, from stratospheric ozone research to hydrology, ecology, climate science, but they're all pointing at risks, which when you add them up, gives you a very compelling justification for action. So that's also another key element in this context. And then finally, I think that what we should do increasingly is to do what Galileo Galilei did when he had his seminal dialogue with Simplicio and Salvatio, trying to show the arguments why it's in fact the planet running around the sun and not the reverse, which is to start with the very basics which nobody disagrees about and build it from there. The fact that the greenhouse effect is agreed by everyone. Otherwise it would be minus 18 degrees Celsius on the planet. We are emitting greenhouse gases, which is acidifying the oceans. That's high school chemistry. Nobody argues about that. We're losing biodiversity. Nobody's arguing about that. And you can build the arguments up to a point where it leaves you with the agenda of the AR5. And I think if you do it that way, you come to a point where you've in fact disqualified much of the uncertainty, or the uncertainty in terms of action at least. Then final point is just to realize that one has to connect, as Professor Pan does, the science with peak oil, that we may in fact be running out of fossil fuels anyway. And thirdly, that there's so much evidence to show that we can gain from a more sustainable world rather than lose. So there's such a social, environmental, scientific argument as well to be made on action.
Okay, thank you very much. So one more. Oh, here we go. Okay, one more scientific question I think that follows directly from your point, and then we'll move to policy, which is climate change is generally perceived as a warming of the atmosphere, but it's actually a toxification of the atmosphere. So can anyone comment briefly on the health effects for humans and plants and animals of introducing such a volume of toxic chemicals into the atmosphere?
I'm mostly concerned with my work on the physical aspects. But I think one has to make a distinction between greenhouse gases and air pollution. When you talk about toxic effects, right? That's more related to the human health arena and could be of shorter term impact and immediate impact than some of these longer term impacts as forced by, say, greenhouse gases. I would like to actually go back to the previous question about whether climate change is real. It is based on good science. There are very fundamental scientific principles which are not disputed in any way. I think the only uncertainty we have is really the quantitative projection of climate change. And I think we have to impress on the general public that the climate system is inherently a very noisy system. It is not just a very simple curve going upward or downward in any way. It has many fluctuations on much higher frequencies, such as on the order of months and years, which might not be related to climate change. It might be related to other forces at work. And sometimes we might be fooled by the fact that suddenly the winter of 2010 was very cold in many parts of the world. And journalists would then approach us and say, is this going into a small ice age or something like that? And I don't think they will ask the same question if they wait long enough and wait for the summer. You have very extended ranges of heat waves in the North American sector. You have the Moscow heat wave, which actually led to a lot of forest fires and so on. So these are weather events which have explainable causes, but not related to climate change. And we have to make the distinction among the two.